A partnership using VR for education. Welcome back to Techstination. I'm Fred Fishkin. With us is PrismsVR CEO and founder Anurupa Ganguly. Hi, Anurupa.
Hi, Fred. How are you? Thanks for having me.
A pleasure to meet you. Give us a bit of background. First of all, really fascinating here about this company. I think you got started in the midst of a pandemic.
We did. We started in 2020, just as schools were shutting down. Just to back up briefly, it was the idea was founded upon my many years teaching. I was a high school math teacher, physics teacher, and led math and science for some of the largest districts in the US, and became really convicted that we didn't have the tools to close the learning gaps at scale, that were just getting worse and worse. During the pandemic, as you might know, about 70% of US 8th graders are not proficient in math today. And that number has been somewhat stagnant over the past 30, 40 years. And so Prism seeks to really reimagine how people experience their mathematics education. And what we do is we immerse them in first-person, real-world problems. Often kids don't know why they're learning the math that they are, and it creates a very high level of disengagement and just disillusionment in the modern math classroom. So by immersing them in real world problems that are relevant, and they can immediately see the connection to society, their lives, and contribution to society. And from those real world math problems, or real world problems rather, they build mathematical models to solve different missions. And so we started with Algebra 1, middle school math, which are the Achilles heel of the secondary STEM program, began to push into Algebra 2, pre-calculus, upper math, and then we release all of science in July, because it's the same methodology or pedagogy that is very scalable across all of STEM, which is this notion of experiencing phenomena, experiencing real life stories, and then modeling and mathematizing them to solve important problems in the world today.
Very interesting. So you partnered with T-Mobile here to try to bring this to more kids. Tell me about that.
Yeah, so the T-Mobile partnership was twofold. One was, this is a brand new hardware for a lot of our school systems, and it is a perceived risk. VR has not yet been entirely validated as a modality of learning. So all the districts that are signing on, they're lighthouse leaders in helping us modulate this new medium for efficacious learning. So T-Mobile first donated class sets of devices to many Title I and rural districts across the US for them to get started and see what it's like. And then what happened was, as schools saw the value and the impact, they began to make those decisions to expand themselves. And the second was, in many of our rural districts, there's very poor internet connectivity. And you do need internet connectivity to run our program, in that kids have a blindfold on their faces and teachers don't have access to what is going on in there. And so to run our data dashboards, to run our multiplayer environments, you need access to reliable internet. So they provided hotspots to make sure that all of our rural districts that don't have access to reliable internet could still use a program as aspirational as ours.
I understand you also have some backing from the National Science Foundation and the NIH.
Yeah, so we were funded by the NSF and the NIH in the early stages of product dev to really kind of get this medium right. Learning in VR is a lot of distractions. There's a lot of visualizations, a lot of movement, a lot of haptics. And if you're not very careful with how you design it, there'll be no learning. There'll be fun and high levels of engagement, but no learning. And so we wanted to do a lot of co-design with kids and teachers initially, and that was all funded by the NSF.
Why VR? And how is this more effective?
I think that for a long time, there were many modalities of learning that just simply were not allowed in the modern math classroom, i.e., like movement, rich visualizations, learning through stories. And could one scale those pedagogies without VR? Maybe, but that is a massive teacher upskilling project you're now looking at, right? So to scale problem-driven learning, you have, having teachers like with their pipe cleaners and cardboard and having like all those manipulatives. And I mean, that's a nightmare for a teacher for 35 to 40 kids in a Title I district to be able to manage. So what VR does is it scales problem-based learning and makes it very doable. A teacher's instructional block is typically 42 to 47 minutes in a traditional high school. So being able to come in, activate a quick conversation, put your headset on, and be transported to a world with all the tools that you need, all the different visualizations and data visualizations. And it just allows a much more scalable and doable instructional model. I was in Boston and New York trying to scale problem-based learning for years. I failed because it's too much for the teacher to implement. So the VR is just the only modality that allows us to scale that pedagogy effectively.
Can you give me a for instance so our audience can maybe better visualize this too?
Yeah, so the first module that we ever built since we were born during the pandemic was on the pandemic. So kids put their headsets on and they're in a food hall and they're buying their food, they're taking in the environment, they're a first person actor, they're not watching a story, they're not watching a video, they're not passive, they're active, and they're moving their bodies. It's not like these mousy movements with a mouse and a keyboard. There's a mayor's announcement and she says there's an alarming growth rate of a virus, stay safe. And the kids are like, wait, what just happened? What is she talking about? And they get the power on their watch to go back in time and see those behaviors that were playing out when they were unaware. How was the virus spreading? So they say, oh, I had heard her sneeze. I didn't realize there was transmission. I saw her friend walk back just 5 minutes ago. I didn't realize another 4 people could have gotten it. So it's a physical understanding of multiplicative growth, not an intellectual one. We haven't used the word equation, function, factor, nothing. Students then accept a mission. How many weeks until the hospitals in your community are going to need more resources? And it's through that question, kids connect that physical understanding that they had in the food hall to 3D simulations outside their body. They then connect that to tactile data visualizations where they can begin to see that exponential curve and the groups of 5 and factor. We still haven't used any academic language yet. From there, they begin to create charts and tables. They begin to go into 2D representations of thought, from which they begin to discern patterns and expressions, from which they build their equation, y is equal to 5 to the t, from which they generalize to y is equal to ab to the x. So that construction of that general form, which kids just memorize because they have no idea where it came from, is now very constructivist through a series of physical experiences, going from the 3D human experience all the way up to the mathematical model. And so what we hear our kids say, like on repeat, is for the first time I understood where that mathematical form came from. And I have very visceral memories of what each of those stand for. So like in the food hall, the cashier, A is equal to 1. He's like, I'll never forget that starting value. I remember he got when he started to spread the virus. B is equal to 5, that growth rate. I remember the 5 people that got it. So again, the visual memories that kids have months and months and months later is really visceral and kind of, again, it kind of goes in their bodies. Einstein has this lovely, whenever he was asked about his mathematical thinking, he always said it was muscular. He talks deeply about the role of kinesthetic movements and its correlation to cognition. So we've tried to really employ that thinking.
Wow, just amazing. So what have you seen in terms of, maybe it's too soon, but results here?
Yeah, I mean, anecdotally, this thing is growing like fire, and it's very, very much led by district leaders, teachers, and kids. We started with about 14 school systems and 10,000 kids. Winter of 2021, we're across 100,000 students and 140 school systems in about 32 states, and we're going to 600,000 students. And it's very much a movement that we're seeing taken forward by teachers who are saying, I've always wanted to teach this way. I always wanted to teach. I just didn't know that. I'm not an engineer. I'm not an architect. So I couldn't explain to students how you use these concepts. They would ask me, I'd look at the textbook, but everything was procedural because that's how the math teachers had taught it. So it's really empowering math teachers to bring relevancy into the classroom. In terms of just mere efficacy, Wested is our research partner, and in our early studies, we saw an average increase of 10% on learning outcomes. What was actually more interesting in those early studies were teachers and maths were saying, it typically takes me 3 to 4 weeks to teach this topic. My kids got it in 1 because they were able to visualize it so swiftly. And so all of that has informed our first randomized control trial that's happening right now across many districts in Ohio. That white paper will be released, and that has a control group, and that'll ascertain how much better and faster do kids learn and grasp core mathematics in a spatialized environment as compared to business as usual.
That's terrific. So you're using the MetaQuest headset right now?
So we run on both the MetaQuest 2 and the Pico Neo 3.
So, and that can be, I guess, fairly affordable technology
Yeah, definitely. I mean, school districts have more money than we typically write about. There's lots of federal funds that school systems get every year. With ESSER, with COVID relief, they had $190 billion. Most of it has still not been spent, and they have to spend it by next year, by next September. So there is no insufficiency of funds. It's having the political will that we ought to do this differently, and that math education has failed about 80% of the population. Only about 20% of us did well in a traditional setting. And that if we're going to really reach all kids, we have to bring new modalities of learning, because people learn through their senses. They don't learn by memorizing.
And of course, the digital divide is always of concern. So I'm sure wealthier school districts could
No, it's the opposite.
invest in this.
It's the opposite. We don't actually, we're mostly in Title I rural districts. We're not really in any wealthy districts. That's actually, again, a misconception. Title I and urban districts urban districts that serve students who experience poverty, they have a ton of federal funding. So they have Title I, Title II, Title III, Title IV. And so most of our districts that purchase Prisms, they use it through using their title funds, Idea B funds. There's a lot of funds for schools that serve needy communities.
Really terrific. But I guess what I was, alluding to was more well-to-do school districts could afford this, I assume.
They could, but they have less money. That's what's interesting about well-to-do districts, is like their per pupil funding from this. I mean, they have parents, of course, that through local taxes and other methods, but most of our products actually taken off in more underserved communities. So I think the wealthy districts have some catching up to do.
That's terrific. And it's available for people in their homes as well. Tell us about that. You kind of branched out, right?
Yeah. So, we wanted to, so this is a very new way of learning. And part of it was people like, what does it mean to learn VR? I'm so sorry, to learn math in VR. What you said, like, can you give me an example? So we wanted to put it out. We're on the MetaQuest store. And it's an opportunity for parents, teachers, families, communities, tutors to purchase the app and experience what it looks like. We only have our grade 7 to 11 math program. We'll be releasing science to all of our schools this summer. And we will not be putting it up on the consumer store as of yet, but the first app will give people the exposure that they need.
Are you looking to bring this into other subject areas too? I know this is your specialty, though.
Yeah, so we started with math, given the acute need in the US. We'll be releasing all of science in July. When I say all, I mean grades 7 to 11. But then we will be pushing into higher ed. We're getting a lot of inbound from community colleges, vocational trade schools, pathways, as well as traditional four-year universities. So I'll be building out all of the evergreen math and science content for the first 2 years of university. And then after we build math and science, we will indeed be pushing into the humanities.
Just terrific. So for more information and where even parents can go to perhaps take a look at this and invest in it, where should they go?
Yeah, so we're on the MetaQuest store. You can purchase us for just $24 a year, and it gives you access to all the content. And for parents who are really looking to help kids love math, I think that we do well in things that we love. We pursue things that we love. And I don't think we've done enough to help our children love their education and build purpose in their education. So for parents who are looking to engage and build an affection for the discipline, and at the same time increase test scores, because that we've been naturally seeing that consequent, we're available on the Quest store for them to experience at home.
Well, congratulations on what you're doing and the innovations, and there's obviously a lot more to come. Anurupa Ganguly, thank you for spending time with us.
Thank you so much. I appreciate it.